Hello friends, I welcome you in lecture number 13 on normal distribution. In this lecture also we will discuss one more question on normal distribution which was asked in GTU exam. So first we understand this question. The lifetime of a certain kind of batteries has a mean life of 400 hours and the standard deviation of 45 hours. Assuming the distribution of lifetime to be normal, find the percentage of batteries with lifetime at least 490 hours with lifetime between 385 and 490 hours. Also find the minimum life of the best 5% of the batteries, and here they have given the values of standard normal table. We are familiar with the standard normal table. We know that in standard normal table the values given are we are given this type of values. Probability that z lies between 0 and small z is given in this table. For example, if I have 0.2 and here I consider 0.02, then this probability 0.087 is nothing but probability that z lies between 0.22, 0 and 0.22 is nothing but 0.0871. So we are given the probabilities that capital Z lies between 0 and small z, and all those probabilities are nothing but area under the standard normal curve between 0 and z. So here this table represents the area under the standard normal curve between 0 and this value of z. Suppose I am interested in the probability that z lies between 0 and say 1.5, then I have to concentrate here. I have to concentrate for z value which is 1.5, and 1.5 can be written as 1.5 plus 0.00. So in this row I have to look for 0.00 and here for 1.5, and whatever is the intersection, that is our probability that z lies between 0 and 1.5. So this is how we find out the probabilities that capital Z lies between 0 and some value of z using this standard normal table. So sometimes they give us the values of this standard normal table in the question itself. So here we don't have to use the table. The values, required values, are already given in the question. So if probability values of probability table are given in the question, then we have to use those values. If they are not given in the question, then we can ask for the statistical table to the examiner or supervisor or invigilator. So here it is already specified that the distribution of lifetime of batteries is normal. So we don't have to decide that this is the problem of which distribution. It is already given that our normal random variable is nothing but lifetime of certain kind of batteries, and it is given that mean of this random variable is 400 hours and the standard deviation is given to be 45 hours, and this distribution follows normal distribution. So we can say that this capital X is a normal random variable with mean mu equal to 400 and standard deviation sigma equal to 45 hours. Now if we have normal distribution, then to find out the probabilities related to this normal distribution, we use the standard normal random variable which we define as z equal to x minus mu over sigma, where x is a normal random variable. So here our mean is 400 and standard deviation is 45. And we know that this standard normal random variable has mean 0 and variance or standard deviation is 1. We have discussed that how to find out the probabilities related to standard normal random variable using related to normal random variable by converting it into standard normal random variable in earlier lectures on normal distribution. We have discussed 12 lectures on normal distribution. So if you have not seen those lectures, then I suggest you to watch those lectures first and then go for this lecture. Now here we have to decide the percentage of batteries with lifetime at least 490 hours. So to find out the percentage of batteries, first we have to decide the probability. We have to decide the probability that lifetime of batteries is at least 490 hours, that is greater than or equal to 490 hours, and lifetime we have denoted by capital X. So we have to decide this probability that capital X is greater than or equal to 490 hours. That is first part. In second part we have to decide the percentage of batteries such that lifetime is between 385 and 490 hours, that is capital X lies between 385 and 490 hours. That is second part. After calculating these two probabilities, we will multiply them by 100 to obtain the percentage of batteries with lifetime at least 490 hours and lifetime between 385 and 490 hours. That is the first part of the problem. After that we have to find the minimum life of the best 5% of the batteries. What is meaning of that? Minimum life of the best 5% of the batteries. So here we have given the percentage of batteries. We are given this type of situation that minimum lifetime of the best 5% of the batteries, that is we have to decide the minimum lifetime. Suppose the required minimum lifetime is say X hours. So X is not given, but we are given that we have to decide the percentage of batteries. We have to find the minimum life of the best 5% of the batteries, that is 5% is given, that is 0.05 is the probability that minimum lifetime. We have to find out the minimum lifetime X such that 5% of the batteries are in that case. So we have to think that how we can find out this small x. Now because small x is the minimum life, therefore value of small x is always less than or equal to the lifetime, which we have denoted by capital X. So if small x is the required minimum life of the best 5% of the batteries, that means lifetime is always greater than or equal to small x. That is, we have to find out value of small x which is minimum. So that we can write in this way: lifetime is denoted by capital X. So we have to decide value of small x in hours such that this probability is 0.05. So this we have to do in this problem. So I have written certain things here to save the time. Here x is nothing but lifetime of a certain kind of batteries. It is given that capital X is normally distributed with mean mu equal to 400 hours and standard deviation sigma equal to 45 hours. And here we have to first decide that what is the probability that lifetime of batteries is at least 490 hours. That is, capital X is greater than or equal to 490. At least 490 means it can start with 490 and it can go beyond 490 also. Now to calculate this probability, we know that we have to convert this capital X, which is normal random variable, in the terms of standard normal random variable. So for that we subtract mean and divide by standard deviation on both the sides. 490 minus mean mu divided by sigma. Now this x minus mu over sigma is nothing but capital Z, and here we put values of mean, which is 400, and standard deviation, which is 45, and this turns out to be probability that Z is greater than or equal to 490 minus 400, that is 90, divided by 45, and that is nothing but probability that Z is greater than or equal to 2. So now I have to decide that what is this probability that Z is greater than or equal to 2, and here I am given the probability that Z lies between 0 and 2 is 0.4772. So using that table value we have to decide the probability that capital Z is greater than or equal to 2. Now we know that capital Z is a standard normal random variable and its graph is a symmetric bell shape curve. Suppose this is the rough sketch of this standard normal random variable. Here we write down the values of capital Z. Suppose this is 2 and this is 0, and we are given the value of this area, that it is given in the table that probability that capital Z lies between 0 and 2 is 0.4772. So let me write that given table value. 0 less than Z less than 2 is nothing but 0.4772, and I am interested in this probability that Z is to the right side of this. So for that we can see that probability that Z is greater than or equal to 2 is nothing but, we know that the area to the left of this 0 and the area to the right of 0 are 0.5, because total area under the standard normal curve is always 1. So area to the right of 0 and left of 0 both are 0.5. So area starting from 0 and extending up to infinity is 0.5. This total area to the right side of 0 is 0.5, and we are interested, and we know that this area between 0 and 2, this area is given as 0.4772, and total area to the right side of 0 is 0.5. So this area can be obtained by subtracting this area from the area to the right side of 0, which is 0.5. So this we can write here as this is equal to 0.5 minus probability that Z lies between 0 and 2, and if I consider 0.5 minus 0.4772, then I will obtain that, let me take the subtract. So this turns out to be 0.0228. So in this way we have to use given table values. We are given the area between 0 and 2, that is we are given this area, and we know that area to the right side of 0 is 0.5, and we are interested in this area. So this area can be obtained by subtracting this 0.4772 from the total area to the right side of 0, which is 0.5, and we find the required probability as 0.0228. So be careful while using this type of tables. It is advisable that we sketch the graph and we understand the areas as probability, and we will be able to calculate probabilities easily. Again I repeat that if we take addition of these two areas, area between 0 and 2 and area to the right side of 2, this is total area to the right side of 0, which is always 0.5. Therefore, this area is equal to 0.5 minus probability that Z lies between 0 and 2. So this is the probability that lifetime of batteries is at least 490 hours, and we are asked to find the percentage of batteries. So for that we will multiply this probability by 100. Therefore, the percentage of batteries with lifetime at least 490 hours is equal to probability that capital X is greater than or equal to 490 hours into 100, and that turns out to be 2.28%. This is first part, that the percentage of batteries, find the percentage of batteries with lifetime at least 490 hours. Now we move for this second part, that we have to find the percentage of batteries with lifetime between 385 and 490 hours, and then we can first find out the probability. So I have written that also. Probability that lifetime of batteries is between 385 and 490 hours, that is capital X lies between 385 and 490 hours. Here also I have to convert in the form of standard normal random variable. So I subtract mean, which is 400, and I divide by sigma, which is 45. Here I will write mu, and here sigma less than 490 minus 400 divided by 45. And if you find out this quantity, it turns out to be negative of 0.33. This is our capital Z, standard normal random variable, and this is 2. So now we have to find this probability that capital Z lies between minus 0.33 and 2. So again we use the standard normal curve for the simplification. Suppose this is our standard normal curve, and suppose this point is 0, say this point is 2, and negative 0.33 is somewhere here, and we are interested in the area between minus 0.33 and 2. Now we are given this area probability that Z lies between 0 and 2, and that is given. So this I can rewrite as that Z lies between minus 0.33 and 2. This area is nothing but addition of this area between minus 0.33 and 0, that is minus 0.33 less than Z less than 0, plus probability that Z lies between 0 and 2. Now we are given this area that we have used here, probability that Z lies between 0 and 2. This area is given, and that is 0.4772. So that I will write here 0.4772. So this is equal to probability that minus 0.33 less than Z less than 0 plus area between 0 and 2, that is given as 0.4772. Now how to find out this area? So for that we can use the symmetry of this normal curve. We again sketch for understanding. This is our normal curve. Now suppose this point is minus 0.33, and because this is symmetric, somewhere here we have positive 0.33, and this is 0. So using the symmetry of this standard normal curve, we can observe that these two areas are equal area between minus 0.33 and 0 and area between 0 and 0.33 are always equal because we have symmetry here. We know that capital Z has symmetric bell shaped curve. So whatever area is here, that is also same. So this I can replace by area between 0 and 0.33. 0 less than 0.33 and this is 0.4772, and they have provided this value in the question, that area between 0 and 0.33 is also given in the question. This is area between 0 and 0.33, that is 0.1293. So that we write here 0.1293. So now I am writing 0.1293 plus 0.4772. If table is not provided, then you can use this statistical table to find out this probability. For example, suppose I am interested in that area that Z lies between 0 and 0.33, then let's try to cross verify. I am interested in this probability that capital Z lies between 0 and 0.33. That means I have to consider small z equal to 0.33, and 0.33 I can write as 0.3 plus 0.03. Okay, I split z in this way, z equal to 0.3, because here under this column they have given values for up to 1 decimal places, and for second decimal I have to concentrate here. So I write 0.33 as 0.3 plus 0.03, and now for 0.3 I have to look for this row. This corresponds to 0.3, and 0.03 corresponds to this column under 0.03, and the point which is at the intersection of these two lines is required point. So let me remove these two lines, and we can see our value is 0.1293. So that is provided. If they don't provide, then you have to write it using the standard normal table, but if it is provided, then that is reducing your work, and this addition is 0.6065. So this is the probability that lifetime of batteries is in between 385 and 490 hours, and we are asked to find the percentage. Therefore, the percentage of batteries with lifetime, therefore the percentage of batteries with lifetime between 385 and 490 hours is equal to probability that capital X lies between 385 and 490 hours into 100, and this is our probability 0.6065 into 100, and therefore required probability is 60.65%. So in this way we can easily answer this type of probabilities. Now in the last portion of the question, we have to find the minimum life of the best 5% of the batteries, and I think we have to use this table value. Now we have not used this table value. Z lies between 0 and 1.65. So somewhere in our calculations we must get these figures 1.65. So now we try to answer that last part, the minimum life of the best 5% of the batteries. So it is we have to decide the minimum life of the suppose we denoted denote it by x hours of the best 5% of the batteries. So if we know that if x is the minimum life of the best 5% of the batteries, that means value of small x is always less than or equal to lifetime of batteries. So we are given that probability that capital X is greater than or equal to say small x is 5%, that is 0.05. So we have to now determine the value of small x. In earlier cases we are given the value of x and we are determining the probabilities. Here probability is given and we have to decide that for which lifetime this probability, minimum lifetime, this probability is 0.05. So now I am standardizing. I am taking this subtraction of mean and divide by sigma. Mean is 400 and sigma is 45 and this is 0.05. This means probability that capital Z greater than or equal to x minus 400 divided by 45, this is given as 0.05. So this means the probability that capital Z is to the right side of this value is 0.05. So let's understand using the table again. Suppose I consider the graph of standard normal curve which is symmetric and bell shape. Okay, we can roughly sketch to understand the values of probabilities. So now it is given that if Z is to the right side of this point, suppose this point is x minus 400 divided by 45. So probability that Z is greater than or equal to this value, that means if we consider area to the right side of this point, then this area is given, this area is 0.05 and we have to use the table also. So we have to convert our probability in this form. Probability that Z lies between 0 and some value of Z. First I have to convert this probability in the form of this type of probability so that I can use the given table value. So that I can do here. Now we can see that area to the right side of this point is 0.05 and now if we consider that if we are interested in this area between 0 and this point, this area is nothing but total area to the right side of 0 minus area to the right side of this point. Area between 0 and this point x minus 400 over 45 is nothing but total area to the right side of 0 minus area to the right side of this point. So that I am writing here. This I can rewrite as 0.5. I am writing this as, I have to write the expression for this. So for that, this area is total area to the right side of 0 minus area between 0 and this point, 0 less than Z less than x minus 400 divided by 45 is equal to 0.05. So again I repeat, from this we can say that if we consider the area between x minus 400 divided by 45, area up to this plus area to the right side of this x minus 400 over 45, this area is nothing but area to the right side of 0, that is 0.5. Therefore this area to the right side of this point, this area is 0.5 minus area between 0 and x minus 400, divided by 45. Therefore, now we are interested in this value, area between 0 and x minus 400 over 45. This is equal to, I consider this on the right hand side, and this is equal to 0.5 minus 0.05, and that turns out to be 0.45. So now you can see that area between 0 and this value, x minus 400 over 45, that is equal to 0.45. Now if you see the table value which is given in the question, they have given that 0.45 is nothing but area between 0 and 1.65. So that we can use here, we can compare. Here they have provided that area between 0 and 1.65 is nothing but 0.45, and here we find that area between 0 and this x minus 400 over 45 is 0.45. So if we compare these two, then we must have this value x minus 400 divided by 45, this must be equal to 1.65, because it is given that area between 0 and 1.65 is 0.45, and here we find that area between 0 and x minus 400 over 45 is also 0.45. So we have both the right hand sides equal, so we must have this value equal to 1.65, and now we can solve this for x and we can obtain the required value of x. If we multiply this 1.65 and 45, we obtain 74.25, and therefore x becomes 474.25 hours. So this is the minimum life of x of the best 5% of the batteries. So in this way we can answer this type of questions also. Here probability is given but value of x is not given, so that also we are able to decide using this standard normal probability table values. All we have to understand is how to use this table. So if you are not comfortable still, then you can watch my lecture number 2 on using the standard normal table. I have explained that in detail in lecture number 2. So this is all about this question and session. I hope you like it. Thanks for watching.